this slide gives a comparison of the two sequencers that are being used by the VIB nucleomics core. Illumina has a lot more sequences than this, but in this slide I will just focus on these two. So sequencers differ mainly in how much reads they can generate. So the MiSeq sequencer uses traditional unpatterned flow cells that have one lane, while the NovaSeq sequencer uses the patterned flow cells with 2 or 4 lanes. The more lanes you have, the bigger the surface you can sequence on, so the more fragments that you can sequence, the more reads you can generate, and that's what you see here. So on a NovaSeq sequencer, you can generate a lot more reads than on a MiSeq sequencer. The length of the reads varies, but since most people go for reads around 100 base pairs, both machines will be okay. So if you have large libraries, you will typically go for a NovaSeq sequencer. When you work with small genomes, you will go for a MiSeq. You don't have to make this choice yourself. Your sequence provider will have multiple sequencers, and they will choose the best sequencer for your project. I would like to come back on these two types of flow cells. So these flow cells are used by the MiSeq sequencer. These flow cells are used by the NovaSeq sequencer. What is the benefit of these patterned flow cells? Well, in patterned flow cells, you get a better distribution of clusters because of the wells that they contain. On a glass slide, you have no control whatsoever on the location of the clusters. If you load a lot of fragments on these flow cells, they will generate overlapping clusters, and this will generate messy data. So on these flow cells, you always have to take care that you don't load too many fragments. On a patterned flow cell, this is not really an issue because the wells form physical barriers between the clusters so that they cannot overlap. This means that on these flow cells, you can load a lot more fragments, which is of course a big benefit. So it seems that these flow cells are better than these, but they also come with a small disadvantage. Long fragments might form bridges towards neighboring wells during the bridge amplification step. And if this happens, you will get clusters in these two neighboring wells that contain copies of the same fragment in the library. So these clusters will be technical replicates, and that's something that you want to avoid as much as possible.